Alright, welcome back to another video on my channel, math_exe, and today we're going to solve this pretty interesting type question, and this involves the pigeonhole principle, which I will explain later. So let's look in the question. It says, show that if we take 6 elements from the set 2001, 2012 all the way to 2020. So if you think about it, there are 10 elements in this set. There must be at least one pair of elements. So that means there's like, for example, if we take 2011 and then we have 2012, this is a pair, and which sum up to this number 4031. Okay, so before I go into this question, I'm going to try to explain what the pigeonhole principle is. So let's assume that we have several pigeons. I'll just mark it as circles, and we have some pigeonholes. I'll denote them as squares. So the pigeonhole principle says if we have more pigeons than pigeonholes, and if we put the pigeons inside these pigeonholes, there must be at least one pigeonhole with at least one pigeon, or probably more than one pigeon. So yeah, so notice the number of pigeons in this case, which is 6, is greater than the number of pigeonholes in this case, which is 4, and 6 is bigger than 4, and therefore you can just try to arrange them and try to make them so that you must have at least one pigeon in every hole, and actually you cannot do that, because yeah, you may try that on your own. You can just test it if you want. So in some math questions, these pigeons can be represented as other different things, like for example numbers or sets, in this case elements, I guess, and the pigeonholes can also represent different things. We can assume they're like pairs, or pairs of numbers, or something like that. So yeah, and first, when solving a pigeonhole principle type question, you must find out what the pigeons and the pigeonholes actually represent. So in this case, our pigeons are the number of elements that we want to take from this set. So I'll just denote pigeons as pi, and this is equal to number of elements we want to pick from this set. So we have the set 2011, 2012, and all natural numbers all the way to 2020, like so. And for the pigeonholes is, if you look at the question carefully, there must be at least one pair of elements which sum up to that. So we need to, actually the pigeonholes are every set of elements from this set, every pair of elements from this set. I'll just box this in green, which sum up to 4031. So if you look carefully, those subsets are 2011, 2020, and notice if you sum that together, we'll get 4031. And next is 2012 and 2019, and you may expect where this is about to go, and we're going to stop at 2015, 2016. And if you switch those places, it doesn't really matter because it will just sum up to the same number for 2031. So if you look carefully, there are 5 pigeonholes, and there are 6 pigeons given from our question right here, right there. So if you want to try to draw like a representation of the pigeonholes and pigeons, you can do that. So remember, there are 5 pigeonholes and 6 pigeons. I'll just mark those in circles. So we can denote this as the representative of our set of pairs we have got, and we have 2011, 2020, and you can just write this and write that. So considering we want to show this applies, we want to assume the worst case scenario, which is if you want to try to make sure that there are 1 pigeon in 1 pigeonhole. So I'll just remove this. I'll just put, remember there are 6 pigeonholes, so we just put 1, 2, 3, 4, and 5 pigeons inside these pigeonholes. And you might know this because we already put 5 pigeons inside. There must be 1 pigeon left, and wherever we want to put this, it must be occupy one of these pigeonholes. And since we want to try to make sure that each pigeonholes must have one pigeon, we have no other option but to put this in either of these 5 pigeonholes. So let's say I'm just going to erase this. Let's say we're going to put this right here. And if you want to assume another case, it also works. If you want to try to put each pigeon into 1 pigeonhole, it also works. As long as you assume the worst case, and that case also claims our statement, and therefore we can just prove this statement that this is true. I'll just put a box right here. So we are done showing. We can just put a box there, and yeah. So I will just probably do some more videos about like the pigeonhole principle and some types of questions involving this. So hopefully you guys will enjoy this video, and please subscribe for more videos, and I'll see you in another video.